Hello students, welcome to the class. So in the previous class, we have discussed about ionization energy. What are the factors governing ionization energy? And apart from that, we have also discussed how does the ionization energy vary in the periodic table. Yes, we have seen so many factors in governing ionization energy. That is, it might be size of the atom, it might be the charge on the nucleus, it might be shielding effect, types of the electrons involved, or completely filled or half filled subshells. Yes, then we have also seen the significance of ionization energy, what it helps us to understand. Moving to the next one, that is electron gain enthalpy. So what do we mean by electron gain enthalpy? Electron gain enthalpy is the energy released when an electron is added to the isolated gaseous atom. It's opposite of ionization energy. See, we know that suppose we have an atom like this. An atom is made up of so many shells, we know, right? So let me say these are the different shells of an atom, and this one is my nucleus, right? So when we know that nucleus contains positively charged and electrons are revolving around the nucleus in these energy levels numbered as 1, 2, 3, and so on. So we know that there is a attraction between the nucleus and the electrons revolving around the nucleus, but the outermost electron will experience less nuclear attraction because of the increase in the distance from the nucleus and also due to the electron repulsion. So this is what we have discussed. Now what we are going to discuss is exactly opposite of it. Suppose I have an atom like this. Yes, and say I have one more atom here. I'll take conditions. Okay, so the energy, what happens is when electron has to be lost, when electron has to be removed, you need to put some energy and you call it as ionization energy. Only when you give sufficient minimum amount of energy, the electron will be removed from the vicinity of the nucleus. From the vicinity of the nucleus, from the attractive pull of the nucleus, it comes out, and then only we say electron is removed. Otherwise, you cannot remove the electron just by saying it. Yes. Similarly, suppose this atom has to gain electron. Suppose this atom has to gain electron. Yes, I'm not saying attraction. No, I'm not speaking about attraction. I'm speaking about gaining the electron. Gaining the electron means what? Gaining the electron means adding the electron into its one of the orbital. Yes, adding the electron into one of its orbital. So suppose this atom has to gain electron. So this atom has to gain this electron. So what I need to do, I need to put some energy on the electron to go into it. Yes, or sometimes the electron will go into the atom very easily. So whenever electron is gained by an atom, whenever electron is gained by an atom, always remember energy is released. Energy is released. Yes. So what do we mean? And that energy is called electron gain enthalpy. Yes. Why it is termed as enthalpy only? The energy, in most of the cases, it is released. In some cases, to make an electron atom gain the electron, energy is absorbed. That means I have to put energy on this electron so that it goes forcibly. We'll discuss on what basis that condition is set. So we say it as electron gain enthalpy. It is denoted as delta. Enthalpy means what? Change in the energy. Electron gain, EG, and since it is at enthalpy, we write it as H. So it is denoted like this, delta EG or delta HEG. I can write it like this also, electron gain enthalpy. EG stands for electron gain. So what is electron gain enthalpy? When an electron is added to the neutral gaseous atom, suppose I have a neutral gaseous atom, I want to add electron to it. Yes, I want to add electron to it. Yes, so when I add electron, it gets converted to what? It gets converted to negative ion. the enthalpy change accompanying the process, whatever change is there in the process, energy change, that energy change is called electron gain enthalpy. So what does electron gain enthalpy tells us? This electron gain enthalpy, it provides a measure of ease with which an atom adds an electron. An atom adds an electron to form an ion, that is negatively charged ion. And if you want to represent it, I will represent it as X stands for my neutral gaseous atom. When it gains one electron, it will form an anion X minus, and whatever energy is released or absorbed, that we say in terms of enthalpy. Understood? So this is nothing but electron gain enthalpy. So let us see what is given here. So X neutral gaseous atom, one electron. So it is X minus anion. So delta H is equal to what? Electron gain enthalpy. Okay. For majority of the elements, the electron gain enthalpy is negative. Now, what does electron gain enthalpy negative means? What do we mean by electron gain enthalpy is a negative? Okay. See, it depending on the element, the process of adding an electron to an atom, there can be release of energy or there can be absorption of energy. Either the energy will be released or the energy will be absorbed. And that depends on what? It depends on the atom. It depends on the atom. Depending upon the atom, the energy can be released or the energy can be absorbed. Yes, therefore I say, depending upon the atom, the process of adding an electron, to an atom, it may be endothermic or exothermic. It may be endothermic or exothermic. That means what? Endothermic means what? Endothermic means energy is absorbed. Energy is absorbed. What does that mean here? It means that to make an electron, for an atom to gain electron, you need to put some energy so that that electron goes into the atom. So if energy is absorbed when electron is being added to an atom, then we say electron gain enthalpy is endothermic, and that is denoted by positive sign. So that time, if electron gain enthalpy, that is, it is endothermic, then we write it as plus delta Heg. We denote it like this, plus positive sign is used. Now, for certain atoms, the electron easily gets attracted, easily goes into the orbital of the atom. It is easily, or I can say, it is easily gained by an atom. The electron is easily gained by an atom. So when it is easily gained by an atom, what happens? Energy is released. Large amount of energy is released. And such process is called what? It is called exothermic. Yes, during the gaining of an electron by an atom, if large amount of energy is released, then electron gain enthalpy is exothermic, and it is denoted by negative sign. So when we say large amount of energy is released, delta H is negative. If large amount of energy is absorbed to put an electron into an atom, then it is delta Heg is positive. That is, energy is absorbed, and the process is said to be endothermic. Now, in which conditions the energy is released or the energy is absorbed? Okay, let us try to understand. So, in which condition the energy is absorbed or energy is released? Okay, fine. Let us take this condition. Okay, so let me say This is the nucleus. And I've considered this atom, and here is one atom. This is the nucleus. Now, if you carefully observe, if electron has to be added to this atom, neutral atom, and in this case, if electron has to be added. See, since the atomic size is large, just imagine I want to add this electron here. Since the atomic size is large, the distance of the electron from the nucleus is more. Yes, so distance of nucleus is more from the nucleus is more. Okay, so as distance is more, or I can say as atomic size is large, this nucleus cannot attract this electron very easily. Yes or no? Because why? Atomic size is large. So since it cannot attract the electron very easily, what I have to do is I have to put some energy, or forcibly I have to put this electron into the atom. I should forcibly make this atom to gain this electron. That time what happens? It will form an anion. Yes, but here with the absorption of large amount of energy, it will form an anion. Understanding? Therefore, in this case, I say the process is endothermic. And I represent delta H Eg, or you can write it as delta EGH anyhow, to be positive. Positive means what? Energy is absorbed. Energy is absorbed to gain an electron by the atom. To gain an electron by the atom. Understood? So when atomic size is large, the energy is absorbed to gain the electron. On the other hand, when atomic size is small, when the atomic size is small, nuclear attraction is more. So when atomic size is less, nuclear attraction is more. So when nuclear attraction is more, what happens? As soon as the electron comes into the vicinity of this attraction, immediately it is gained by the atom. So immediately the electron is gained by the atom. So because since it is gained by the atom immediately, what happens? Large amount of energy will be released. Large amount of energy will be released. So therefore, when large amount of energy is released, what do I say? I call it as exothermic process. I call it as exothermic process. And delta EGH will be what? It will be negative. So for a given atom, delta HEG is negative means what? Suppose I'll say for a given atom, delta HEG is equal to minus 496. That means what? That means when an electron is gained by that particular given atom, so much amount of energy is released. So how much more negative the value is of electron gain enthalpy? So what I conclude saying, more the negative value of electron gain enthalpy, more is what? More is the ease means what? Easily to gain electron by the atom. And when more the negative value of the electron gain enthalpy, when is the negative value more for electron gain enthalpy? When it is more? When smaller the size of atom, smaller the atomic size. So can I conclude saying like this? More is the negative value of electron gain enthalpy, more is the ease to gain electron by the atom, and the process is said to be exothermic. It is said to be exothermic. Yes. Now with so much of explanation, can you just explain me across the period, when you move across the period, how does electron gain enthalpy varies? And when I move down the group, how does electron gain enthalpy varies? Does it depend upon the atomic size? Yes, it obviously depends upon the atomic size. If I say the atomic size of this side at the left, it is so much. As you move across the period, atomic size, what happens to the atomic size? atomic size decreases, right? Atomic size decreases. Are you all getting? So as we move across the period, atomic size goes on decreasing, correct? And as we move down the group, atomic size is what? Atomic size is increasing. So atomic size decreases across the period. Here atomic size increases down the group. So as atomic size, so across the period I'm talking about. Okay, across the period. As atomic size it decreases across the period, nuclear attraction, what happens? Nuclear attraction increases. Therefore, the electron can be gained. Electron can be gained very easily. It can be gained very easily, thereby releasing large amount of energy, thereby releasing large amount of energy. Therefore, can I say across the period when you move from left to right, the electron gain enthalpy becomes more and more negative. Yes, or I can say across the period when you move from left to right, the negative value of electron gain enthalpy, it increases, correct? It increases. So it becomes more and more negative. Yes. As you move down the group, what happens? As you move down the group, as atomic size increases, nuclear attraction decreases. Therefore, to gain an electron, energy is what? Energy is absorbed. To gain an electron, energy is absorbed. Therefore, I can say down the group. Yes, what I can say, down the group, as you move from top to bottom, electron gain enthalpy becomes less and less negative, or here in this cases it is not negative. If you look at for metals, it becomes more and more positive. Because what happens, it becomes more and more positive because for metals, since atomic size is very large, you need to put some energy so that the electron is gained by the atom. So when you're putting energy, electron gain enthalpy is what? It is positive. And in this case, the process is what? The process is endothermic. So across the period, the electron gain enthalpy becomes more and more negative. That means more and more amount of energy is released. When you move down the group, the electron gain enthalpy becomes more and less negative, or more and more positive. Yes. So this is about electron gain enthalpy. So let us see what we have. For majority of the elements, electron gain enthalpy is negative. For example, the electron gain enthalpy for halogens is highly negative. There is one more reason here. Yes. Why it becomes negative? First reason is the atomic size. What is the second reason? The second reason is, see, if you look for group 17 elements, electron gain enthalpy is highly negative. I can say it is highly negative. That means the particular atom will gain electron very extremely easily with release of huge amount of energy. Yes. Why is it so? The reason is, if you see for group 17 elements, what is the outermost configuration? General configuration I'm saying, it is ns2 np7. Yes, so here if you look here, spin up, spin up, spin up, spin down, spin down. So it is having this configuration. Yes, what is this configuration? If you see these 17 group elements, just by gaining one electron, just by the gain of one electron, they will attain 8 electrons in the outermost shell. They will have 8 electrons. So they will attain 8 electrons. Outermost shell configuration is called stable electronic configuration, as that of what? As that of what? As that of noble gases. Or I can say they will attain stable octet configuration. So these are the two reasons. They will attain stable octet configuration. Therefore, they will gain the electron very easily. Yes, immediately by gaining one electron, they will attain stable. For example, fluorine atomic number is 9, 1s2, 2s2, 2p7. See, it is having 7 electrons in its p orbital. I'm sorry, 2p5. So it is having 7 electrons in its outermost shell. Just by gain of one electron, just by gain of one electron, it becomes 1s2, 2s2, 2p6. It will have 8 electrons in its outermost shell. It will form an anion. It will have 8 electrons. So it is stable configuration, or you can say it is octet configuration, which is very stable. Yes, therefore this is second reason. This is second reason. Yes, so the electron gain enthalpy of group 17 elements is very, 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 very negative because of these two reasons. One reason, atomic size is extremely small. Extremely small. Second reason is what? Second reason is, as soon as they gain one electron, they will attain the stable configuration of octet configuration. Therefore, because of these two reasons, they will gain the electron very easily. For example, the electron gain enthalpy for halogens is highly negative because they can acquire the nearest noble gas configuration by accepting an extra electron. In contrast, noble gases have a large positive charge, positive electron gain enthalpies. Because why noble gases have large positive electron gain enthalpies? Because if you see noble gases, what is the configuration of noble gases? The configuration of noble gases, suppose you take neon 10, it is 1s2, 2s2, 2p6. Therefore, in general, I can say noble gases have configuration ns2, np 6. So they have stable configuration in their valence shell. Stable configuration in valence shell. Or I say stable octet configuration. Or I can say they have completely filled configuration. Completely filled configuration. So when they have very stable configuration, can they gain the electrons? Can they gain the electron? No, they are very stable now. They do not need anything. So if you want to make it gain electron, very, very forcibly you have to make it gain. Why I'm saying very forcibly? Because they are very stable now. Octet configuration, completely filled configuration is highly stable. It is highly stable. So you want to make it a gain electron, that means you need to put large amount of energy. Therefore, electron gain enthalpy will be highly positive for noble gases. It will be very positive for noble gases. Yes. So noble gases have large positive electron gain enthalpies because the extra electron has to be placed in the next higher principal quantum energy level, thereby producing highly unstable electronic configuration. Highly unstable electronic configuration. Is that clear? Okay. Successive electron gain enthalpies. Okay, let us try to understand successive electron gain enthalpies. Electrons from the gaseous atoms are lost in succession. That is, again, like how we discussed about ionization enthalpies. What we discussed in ionization enthalpy, suppose you have a neutral gaseous atom, you want to remove electron from the outermost shell, apply first ionization energy, one electron comes out. Now you take that metal ion, that is unipositive ion, apply second ionization energy, one more electron comes out. The next outermost electron comes out. Take a bi-positive ion, apply the third ionization energy, the third electron comes out. Understanding? Again, take the tri-positive ion, apply fourth ionization energy, the fourth electron comes out. Understanding? So this I1, IE1, IE2, IE3, IE4 are called what? They are called successive ionization energies. So what we say, the electrons are to be removed. The electrons are removed from an atom simultaneously. The electrons are removed from an atom simultaneously. Is it right? No, the electrons are removed from an atom not simultaneously. They are removed from an atom successively. I cannot say that you remove the electrons from the atom simultaneously. We remove it successively. What do we mean by successively? One after the other. If I am removing first electron, then after removing the first electron from the valence shell, I can remove the second. After removing second electron, I can remove the third electron and so on. So we say successively the electrons have to be removed. I cannot just anyhow remove. Similarly, electron gain enthalpy, yes, is also, there are also successive electron gain enthalpies. What does that mean? Suppose I have a neutral gaseous atom. Yes, I want to make it gain electron. I will use electron gain enthalpy. Yes, and it becomes X minus. So this is first electron gain enthalpy. First electron gain enthalpy. Yes, it might be positive, it might be negative. So electron gain enthalpy might be negative or positive. If it is negative means what? That means to gain this electron, when this atom is gaining this electron, huge amount of energy is released. That means electron is gained by the atom very easily. It is positive means what? And the process is exothermic for this. The process is exothermic. Positive means what? For an atom to gain this electron, huge amount of energy is required. You have to forcibly put this electron into this atom. That means you are giving energy. Therefore, delta electron gain enthalpy is positive and the process is endothermic. Process is endothermic. Yes. So, suppose I have X minus ion, gaseous ion, then I wanted to gain one more electron. I will apply electron gain enthalpy to make it X minus 2. Do remember the second electron gain enthalpy is always positive. Yes, the first electron gain enthalpy may be negative or positive, but the second electron gain enthalpy is always what? It is always positive. That is, the process is always endothermic. Let us understand why. Let us try to understand. So let me say I have an atom. Okay. Fine. Okay, this is the atom and this is the nucleus. Now see, suppose it is having so many electrons. So this is having so many electrons. I say, I want to make this atom gain electrons. Okay, so what I will do, if the atom is small, if atomic size is small, then it will gain the electron very easily and electron gain enthalpy will be negative. Okay, if atomic size is large, then nuclear attraction is less. Therefore, we have to make forcibly gain the electron. So it will be positive. In this case, it will be exothermic, we say. And in this case, we say it is endothermic. Okay, endothermic. Okay, that is the first case. Okay, let me say this atom is small. So it will gain the electron very easily. It will form an anion. Let me represent it as X. It will form anion X minus. Yes, and delta EGH or HEG is negative. That means process is endothermic. Now here how many electrons I have represented? 2, this is 10, 13 electrons are there. Okay, here it has gained 1 electron. So it has formed how many electrons now? X minus has 14 electrons. Earlier, the nuclear attraction for this atom, it was distributed. So nuclear attraction was distributed to 13 electrons. Now, as number of electrons increase, nuclear attraction on all electrons decreases. Yes or no? It decreases on all electrons, decreases, because the here, look here, this nuclear attraction is for 13 electrons. In this case, the nuclear attraction will be for 14 electrons. So it divides among 14 electrons. And also, since the electron number increases, there is electron repulsion. Understanding? There is electron repulsion. So atomic size will increase. Yes, yes or no? Now if I have X minus ion and if I want to make it gain electron, that time what happens? Because of all these three criteria, the next electron which has to be gained, I need to put energy to make it X2 minus. Therefore I say the second ionization energy will be positive. The first electron gain enthalpy will be positive. The first electron gain enthalpy may be positive, may be negative. It depends upon the atomic size. But the second electron gain enthalpy will be always positive. It will be always positive. So how do we explain this? When one electron is added to an atom, it becomes, so when one electron is added to an atom, yes, so to an atom, when one electron is added, it becomes negatively charged ion, which is called as anion. Now, if we add the second electron to this negatively charged ion, it experiences what? It experiences repulsive forces. It experiences repulsive forces due to what? Due to electrons already present in that shell. Yes, so it experiences repulsive forces due to electrons already present in that shell. So additional energy should be provided. Additional energy should be provided. Correct? Yes, this is second what I am speaking. First, I hope you have understood. Yes, first what I have told, electron gain enthalpy means what? It is enthalpy change associated with an isolated gaseous atom. When an electron gains when an atom gains an electron to form an ion. Okay, on the basis of the nature of the element, means what? Whether the atom is big or the atom is small. On the basis of the nature of the element, the process of accepting the electron in an atom can be either exothermic or it can be endothermic. In general, energy is released when an electron is added to an atom, and electron gain enthalpy of such elements is negative. The electron gain enthalpy of halogens is highly negative because it needs only one electron to achieve the nearest noble gas configuration. And for noble gases, it is highly positive because extra electron has to be placed in the next higher energy level, which requires lot of energy. Okay, when one electron is added to an atom, it becomes negatively charged ion called anion. Now, if we add the second electron to this negatively charged ion, the ion will experience what? It experiences repulsive forces due to the electrons already present in that shell. So additional energy should be provided to overcome what? To overcome these repulsive forces. Correct? Hence, the second electron gain enthalpy is positive and the process is endothermic. Yes, I can give you a best example. Yes, when an electron is added to sulfur. Yes, when an electron is added to sulfur atom to form what? To form S minus ion. Yes, it releases energy. It releases energy. Therefore, what I can say, the process is exothermic because delta Eg H1 is negative. H1 is negative. Yes. Whereas the energy is required when another electron is added to this sulfur anion to form S minus 2 ion, to form S minus 2 ion. Yes. So how do I represent this equation? I write it like this. So first electron gain enthalpy. Yes. Delta Eg H1. Let us see. Sulfur neutral gaseous atom is there. It will gain one electron and forms S minus 1. Yes. So I'll give you example also. Delta H Eg1 for sulfur to gain one electron and form sulfur minus ion is minus 200 kilojoules per mole. Per mole. That means 200 minus means what? 200 kilojoules of energy is released. So what does this mean? Energy is released. Or I can say process is exothermic. Okay. Now, S minus 1 ion, it will gain one more electron and it will gain forcibly to form S minus 2 ion. The delta EgH2, that is second electron gain enthalpy, is plus 590 kilojoules per mole. So what does plus 590 kilojoules per mole says? That means for sulfur minus 1 ion, uni-negative sulfur ion to form di-negative sulfur ion, energy is absorbed. 590 kilojoules of energy is absorbed. Or you can say the process is endothermic. The process is endothermic. Yes, the process is endothermic. Getting it? So this is all about electron gain enthalpy. Electron gain enthalpy. So electrons from gaseous atoms are lost in succession, that is one after the other. Similarly, these are also accepted one after the other. Like how electrons are lost one after the other in succession, they are also gained one after the other, that is in succession. After the addition of one electron, the atom becomes negatively charged. So first electron gain enthalpy may be negative, may be positive. When it is negative, when electron is gained very easily. And when it is positive, when we have to put certain energy for an electron to make it gained by the atom. But the second electron is to be added to a negatively charged ion. But the addition of second electron is opposed by electrostatic repulsion of what? Electrostatic repulsion of the electrons which are already present. Hence, the energy has to be supplied for the addition of second electron. Thus, the second electron gain enthalpy of an element is always positive. Yes, here the example of oxygen is given. For example, when an electron is added to oxygen atom to form O minus ion, energy is released. But when another electron is added to O minus ion to form O minus 2 ion, energy is absorbed to overcome the strong electrostatic forces, repulsive forces between the negatively charged O minus ions and second electron being added. So you can see there oxygen neutral atom is there. You are adding an electron. It becomes O minus delta H Eg1. So I will represent this as delta H Eg1. Yes, negatively charged electrons of O minus ions and second electron being added. Okay. So Eg1 is minus 141 kilojoules per mole. That means so much amount of energy is, minus sign means what? Released. So much amount of energy is released when one mole of electrons are added to 1 mole of oxygen atoms to make 1 mole of O minus ions. Second, electron gain enthalpy. To O minus ion, when electron has to be gained to form O2 minus, the second electron gain enthalpy is plus 780 kilojoules per mole. That means 780 kilojoules of energy is absorbed. Positive sign indicates what? Energy is absorbed to for by O minus ion to gain the second electron. To gain the second electron. Yes, this is the successive electron gain enthalpies. Factors on which electron gain enthalpy depends. Okay, atomic size. As the size of the atom increases, the distance between its nucleus and the incoming electron also increases, and thus electron gain enthalpy becomes less negative. So atomic size, as it increases, electron gain enthalpy becomes less negative. That means it becomes more and more positive, you can say. Nuclear charge. With the increase in the nuclear charge, force of attraction between the nucleus and the incoming electron also increases. Thus electron gain enthalpy becomes more negative. Yes, so nuclear charge, as it increases, so it will pull the incoming electron more strongly. So when it is pulling the electron more strongly, the energy will be released. Therefore we say electron gain enthalpy becomes more negative. Next, symmetry of electronic configuration. The atoms with symmetrical configuration having fully filled or half filled orbitals in the same subshell do not have any urge to take up extra electrons. They don't need extra electrons, right? They are stable. If I am stable by my knowledge, I don't worry what others are speaking beside me. If I have entire knowledge regarding that particular concept, right? So I'll be stable at that time. I'll be able to battle any type of questions which are posed to me. But if I have a little doubt also, there will be unsymmetry, there will be instability, right? Therefore anything which is in symmetry is stable. Yes, so the atoms with symmetrical configuration. What is symmetrical configuration? Either having completely filled orbitals in the subshell or half filled orbitals in the subshell. So such atoms with symmetrical configuration, they do not have any urge to take up extra electrons. They don't want to take electrons, neither they don't want to lose electrons. Yes, that's the reason we say they are unstable, they are very stable, or that's the reason we say they are very unreactive, they do not react. Yes, so because their configuration will become unstable if they gain. In that cases, if there is fully filled or half filled orbitals, or in case of noble gases, the electron gain enthalpy is highly positive. So in that case, the energy will be needed and electron gain enthalpy will be positive. For examples, noble gas elements have positive electron gain enthalpies. They have positive electron gain enthalpies. Variation of the electron gain enthalpy across the period. So because before going to this, what is the importance of electron gain enthalpy? Yes, certain properties of the elements are predicted. See, I'll tell you the importance first, then we'll see the variation as we discussed in ionization enthalpy. So what is the significance of electron gain enthalpy? Yes, certain properties of the elements are predicted on the basis values of electron gain enthalpies. The elements having high values of electron gain enthalpies, if the elements, the atoms of elements, I can say, atoms of elements with highly negative electron gain enthalpies are capable of accepting electron. They are capable of accepting electron very easily. Very easily. And form what? And form anions. Yes. And such atoms, they involve in what type of bonding? They involve in electrovalent bonding. electrovalent bonding and form electrovalent compounds. Electrovalent bonding is nothing but ionic bonding. Yes, it is ionic bonding. So this is one, predicting the properties of the atoms, of the elements. Second thing, the atoms having high values, high negative values, the atoms having high negative values of electron gain enthalpies, they are highly oxidizing in nature. So they act as oxidizing agents as they gain electrons very easily. We saw for metals, they have high ionization energies, they have very low ionization energy and they act as reducing agents, whereas those which have high negative value of electron gain enthalpies, they act as high oxidizing agents. For example, you have fluorine, you have chlorine, bromine, oxygen, sulfur, etc. They act as oxidizing agents. They tend to accept electrons very easily. Yes, on the basis of general trend of ionization energy and electron gain enthalpy, you can speak about metallic and non-metallic characters. You can speak about metallic and non-metallic characters. What is all about this metallic and non-metallic character? Explanation I'll give you after few slides. Yes, we can speak about metallic and non-metallic characters. Yes, so even stay, so we can discuss all these points if we know electron gain enthalpy. So that is the significance of electron gain enthalpy. Significance of electron gain enthalpy. Now, variation of electron gain enthalpy in the periodic table across the period. Electron gain enthalpy becomes more and more negative with increase in the atomic number across the period. That is, when you move from left to right, when you move from left to right in the periodic table like this, electron gain enthalpy becomes more and more negative with the increase in atomic number. In the modern periodic table, on moving from left to right across the period, atomic size of the elements decreases. Yes, because atomic size decreases. Effective nuclear charge increases. So when nuclear charge increases, force of attraction between the nucleus and the added electron also increases. So what electron has to be added? The force of attraction between the nucleus and the electron to be added, or you can call it as incoming electron. Incoming electron. It increases. Hence, electron is gained very easily and large amount of energy is released. Hence, electron gain enthalpy becomes more negative while moving across the period. Across the period. Variation of electron gain enthalpy in a group. Electron gain enthalpy. Electron gain enthalpy becomes less negative as we go down the group. Why? Generally, when we move down the group, in a group becomes less negative. Electron gain enthalpy becomes less negative. This is because as we go down the group, both the atomic size increases, atom becomes more bigger, nuclear charge also increases, but effect of larger atomic size is more prominent than that of nuclear charge. Hence, the force of attraction between the nucleus and the incoming electron, added electron, decreases. And this enthalpy becomes less negative. The enthalpy becomes less negative. Okay? You can see here. Across the period. Yes? As you move across the period. Lithium is there, nitrogen, oxygen, fluorine, and so on. Yes? It is for fluorine, it is, see, minus 328. So much energy is released. Now, if you see here for chlorine, it is 349. Yes, that is because of the atomic combined effect of atomic size and electron gain enthalpy. Okay. So, for noble gases, it is positive. As you move down the group, the electron gain enthalpy becomes less negative. It becomes less negative. Okay. Next concept, electronegativity. Yes, we have seen this term electronegativity when we were discussing characters of metals to physical properties of metals and non-metals. Metals are electropositive. They have electropositivity character. Non-metals are electronegative, we said. a qualitative measure of the ability of an atom in a chemical compound to attract shared electrons to itself is called electronegativity. Yes. See, ionization energy, we measure. How do we measure it? We measure it as kilojoules per mole. Electron gain enthalpy, how do we measure? We measure it as kilojoules per mole. But electronegativity is not a measurable quantity. It is just the tendency of an atom in combined state. Yes. Now you may say, then what is the difference between electron gain enthalpy and electronegativity, right? A very good question to ask. Electron gain enthalpy. I'm sorry. Electron gain enthalpy. Delta EGH. This side we have electronegativity. It is En. We write it as like this. Yes. This is a measurable quantity. Yes. This is also a measurable quantity. It is having scales. Quantity. Yeah. This electron gain enthalpy is what I'll tell you. See. When you have an atom, when we say electron, speak about electron gain enthalpy, when this electron is actually gained by the atom. That means when we say electron is gained, when we say electron is gained, it means this electron has entered into the orbital of this atom. Understanding? So we speak about isolated atom gaining the electron, correct? Gaining the electron. What is electronegativity? It is the tendency to attract. Yes, or I can write it like this. Yes, when I speak about electronegativity, I will not consider isolated atom. I will consider a molecule. Let me say I have HCl molecule. So this is H and this is Cl. So there are nucleus, right? So this is the nucleus. Now, in this case, if you see HCl, when we speak about a bond between H and Cl in HCl molecule, a bond is always formed. Single bond is there. It will be always formed by 2 electrons. Do remember this. So these 2 electrons, if the molecule is H2, this is H2 molecule, just imagine. If the molecule is H2, atomic size of both atoms is same. So the electrons will be present at the center of both the atoms. So these 2 electrons will be for this hydrogen atom and they will be for hydrogen atom also. But in this case, since the atomic size of chlorine is less than the atomic size of hydrogen. So this is chlorine, this is hydrogen. What happens is the nuclear attraction of chlorine will be more. Nuclear attraction of chlorine will be more. Therefore, what it will do? It will attract what? It will attract the shared pair of electrons. Understanding? Shared pair. This is the shared pair. In a bond means what? It has shared pair of electrons. So it will attract the shared pair of electrons slightly towards itself. So the electrons are not added into the orbital. No, electrons are not added into the orbital. They are slightly attracted. And this case comes when it is not a isolated atom. It should be a molecule. So in case of molecule, what happens? There is attraction of shared pair of electrons. Understanding? Yes. So here it is gaining of single electron, one electron. Yes, here attraction of shared pair of electrons towards itself. So here the electrons are attracted towards chlorine less than hydrogen. Understanding? So near chlorine, the electron density is more, we say. The electron density is more. But in this case, the electron is actually added into the orbital. Third case, it is measured in kilojoules per mole. It is energy change. Here, it is unitless. It is not measured in any units. Instead, it is being given by scientists. Different scientists have given the scales. One scale is Pauling scale. It has the measure of values. Most electronegative value ranging from 0.7 to 4. Most electronegative is 4 and least electronegative is 0.7. Understanding? So this one, this electron gain enthalpy, it can be positive, it can be negative or negative. It can be 0 also. But electronegativity, it varies from 0.7 to 0.4 only. It is always positive. It is always positive. Okay. So this is the difference between electron gain enthalpy and electronegativity. So let us say what our points say. Unlike ionization enthalpy and electron gain enthalpy, it is not a measurable quantity. However, a number of numerical scales of electronegativities of the elements, namely Pauling scale, Millikan-Jaffe scale, Allard-Kochow scale, have been developed. The electronegativity of any given element is not constant. It varies depending on the element to which it is bound. So here we have one more difference. What is the difference? The difference is electron gain enthalpy. It does not vary for atoms. So I cannot say electron gain enthalpy for sulfur is negative in case of in one case, in another case it is positive. No, I cannot say that. It is fixed for sulfur. Electron gain enthalpy is so much. First electron gain enthalpy is so much. Second electron gain enthalpy is so much. But electronegativity, it varies. Yes, to which atom it is bonded in the bond during the bond formation, to which atom it is bonded, depending on that it varies. So this is all about electronegativity. Yes, how do we explain this? How do I explain this? When atoms bond with each other to form molecules, when atoms bond with each other to form molecules, they share their electrons. So this will share one electron. It depends. There might be transfer also. Here I am speaking about sharing. So if there will be mutual sharing, if this is sharing one electron, this will also share one electron. So when I can represent this molecule like this, where it is shared by one electron pair. Yes, this sharing of electrons is really what creates the bond. Is really what it creates the bond. So bond is created. If there is a single bond, there is sharing of one electron each, or a pair of electrons, we say. Pair of electrons. Yes, just like children sharing their toys unequally. Yes, some atoms are going to be better at sharing the electrons than others. It depends. Some will give up their electrons completely, some will share equally, and some will not so much share but instead take other atoms electrons completely. It depends. This unequal sharing of electrons in a bond is due to difference in electronegativities. So what is electronegativity? It is the ability of an atom, it is the ability an atom has to attract the shared pair of electrons. Atoms that have high electronegativities will attract more electrons and may even steal from other atoms. If the electronegativity is very high, electron gain enthalpy becomes negative. You can say like that. Yes? Cleared? So this is about electronegativity. Electronegativity. What is electronegativity? The tendency of an atom, to attract, please do remember, to attract the shared pair of electrons towards itself. And this is possible when the atom is in combined state. You cannot speak about electronegativity of chlorine individually. You can speak about electronegativity of chlorine when it is bonded to some atom, say hydrogen. When it is bonded to some atom, say oxygen, then only I can speak about electronegativity. So it should be in combined state. And this is just attraction. It is just a pull, yes, of the shared pair of electrons towards it. And when this electronegativity arises, when the atom is small enough. When the atom is small enough. So what are the factors affecting electronegativity? Yes, so the tendency of an atom in a compound to attract a pair of bonded electrons towards itself is known as electronegativity of that atom. It is important to note that electron gain enthalpy and electronegativity both are what? They are measure of electrons attracting power. But electron gain enthalpy refers to what? It refers to an isolated atom gaining electron. And electronegativity refers to what? It refers to atom in combined state. Atom in combined state attracting electron pair. Here gaining single electron at each time, and here attracting the electron pair. Thus electron gain enthalpy is the, you can say it is attraction for single electron, whereas electronegativity is attraction for pair of shared electrons, or you can say bonded electron pair. Yes, so electron gain enthalpy is the energy. Electron gain enthalpy is what? It is energy, whereas electronegativity is what? It is the tendency. It is the tendency. Yes, factors. What are the factors which affect if electronegativity? First one is what? Size of the atom. In the combined state, if let me say this is atom and this is another atom in the combined state. So since the size of, let me say this is atom A, this is atom B. Size of atom B is less than atom A. Therefore, I can say B is more electronegative than A. That means B will attract the electron pair more strongly. B will attract the electron pair more strongly. The second point is electronic configuration. Small atoms attract electrons more than the larger ones, and therefore they are more electronegative. Secondly, atoms with nearly filled shells. Fluorine 1s2, 2s2, 2p5. So this is having 7 electrons. This is said to be nearly filled shell, because which is completely filled 8 electrons, and this is having 7 electrons. So it is said to be what? It is said to be nearly filled shells. Yes. So atoms with nearly filled shells of electrons will tend to have higher electronegativity than those with sparely filled shells. Is that clear? So this is about the electronegativity. Variation of the electronegativity in the periodic table, we'll discuss it in the next class. For now, I give you a small work. As you know about electronegativity, it is the tendency of attracting the shared pair towards itself. Just try to get certain information regarding electropositivity. Electropositivity is for what type of atoms? Yes. Okay. So next class we'll discuss about the variation of electronegativity in the periodic table. Hope you have understood. For now, thank you.